Actually, I work until 2 a.m. Here time,
Oh, okay,
in
okay.
highest time. So yeah, 8 a.m., 9 a.m. is like little early for me.
Oh, okay,
That's
okay.
the reason I couldn't wake up sometime.
Mm-hmm.
Yeah, if I do not respond, right, just give me a WhatsApp.
Yeah.
Most probably I'll be sleeping. So just
Okay.
um, let me just bring up the syllabus. Okay,
Okay.
so we'll go with CCNA syllabus as per the Cisco website. So you know Cisco, right? I think Cisco is the market leader in the networking products. They hold 70% of the market stake. So you take any customer, they will be using at least one of their products. At
Okay.
least 50% of the network will be composed of Cisco devices. So even the job opening, everything is related to Cisco devices only. They would, the job responsibilities and requirements, everything will be focused on listing out the Cisco products. So you should have worked on these models of Cisco devices. You should know these protocols of Cisco. So that's all. There
Okay.
are other players also, but most of the customers and most of the enterprise network is composed of Cisco. So that's why you have same certification, same level of certifications with the other vendors. So if you go with Juniper, Juniper has JNCAA, and then if you are going for Palo Alto firewall, they have PCNA. So sorry,
Okay.
PCSA. So they have all the associate level certification, but CCNA is very critical.
Yes.
Let me share my screen. So this is the syllabus that you're going to follow. I'll message you here on the group. So just gives you details about exam. That's okay. So this is our syllabus. Some network fundamentals.
Mm-hmm.
It will just give you a brief about the components involved, the type of topology, and the basics of protocols before you understand how the packet flow works. And then you slowly get into configuration deployment steps related to VLANs. You have heard about VLANs and all, right?
Yeah, heard about it.
Yeah. We will see how it is done.
Okay.
So then IP connectivity, IP services. So initially there are not much labs, so we will just go as the thing progresses. Just have it in your memory that these all the things are there, and you would need to uh, refer this in the later part of the sessions, but you don't need to focus much here. So most of the theories are okay. So as you work, right, in your job role, you will be just dealing with this day-to-day things. So you don't have to worry much about this theory. Okay, access VLAN. So yeah. So let's start with the let's start with the network fundamentals. Okay.
Mm-hmm.
Mm, Let me bring up a whiteboard. Just keep this aside. Okay, let's still see your So I'll give you the PPT after the session, sir. So
Okay.
once we complete the session for the day, I'll send you the relevant PPTs to you
Okay.
so that you can refer or revise for your before your next class.
Okay.
Okay. So yeah, let's start with the routers. So the first topic for the class is network fundamentals. Okay,
Okay.
network fundamentals. So we will first deal with routers. Okay. See, in network, right? What happens? We do not have one device, right? That does multiple jobs. So we have different devices uh, named for its different purpose, uh, its requirement and everything. So why we don't keep everything at one device, right? Isn't it better that you keep everything in one box, uh, right? It makes compact. It makes your network compact. You don't have to do a lot of cablings. I mean, you don't have to allocate a lot of rack space to mount those devices. And even your troubleshooting might look easy because you have everything at one place, right?
Hmm.
So the first reason why we don't have everything at one device is it requires a CPU for every. So what happens is router is a device. It has a special engine called routing engine that is tied to the CPU. So which is required to make routing lookups. So whenever a routing lookup has to be done, I'll tell you what is routing lookup. Okay? Routing lookup is nothing but searching a route in the routing table. Searching a route. I'll tell you what is route. Searching a route in the routing table. In routing table.
Yeah.
Okay. So route is nothing but the destination IP. All boils down to one point: destination IP or destination network.
Yes.
Okay. So the router needs a routing engine. What does the routing engine? It helps you perform routing lookup in the routing table for a route. And what does a route mean? It is a destination IP network, right? So similarly, for everything, if you're going for, I'll tell you. Uh, so routing engine is separately tied to the CPU, right? So you might require 8 core routing engine, depending upon the size of your network, right? 8 core CPU in the router. So this CPU will be completely dedicated for the routing lookup process. So it will be able to all your internet requests, like when you want to reach internet. So it will just save this. It saves? It saves the route cache as well. So I'm not sure if you've heard about the word control plane and data plane. It is very advanced,
Okay.
but still. So there are two planes that is in the routers. So one helps you take correct decision. Other one follows the decision taken by the control plane. Okay. So just remember this. For now, this knowledge is enough. So the router has two planes. You won't see that directly. You can't physically see that, or even you cannot distinguish through a logical way. Like you don't have a different tables, but it performs two functions internally: control plane, data plane. Control plane helps you decide which route is best for your destination,
Okay.
and data plane just extract that information and follow the route. That's it. It's just like a leader, and then this is like a student. Okay.
Okay.
And what does a router do? Now the function is so you know routing engine, routing lookup, and we have to have a dedicated architecture for its work. Right? Then what does a router do? It helps you route. Route in the sense, can say like guide and just ordering it to send the traffic from one place to another place. Okay, route in the sense guide, route the traffic
Yes.
between two or more networks. So router is not needed to route traffic within a network. When you want to send traffic from one network to another network, you need a router. Clear?
Okay.
And router is a L3 device. Okay? L3 device in the sense layer 3 device. Let's see where does this model comes. Okay, I don't see USA models added as intelligence. Okay. Once we complete the components, then we will move into voice models. Okay. So this is a brief about router. Okay.
Yes.
And have you made any notes, or can you just switch or erase this?
I'm making light notes. So
Okay.
yeah,
Then it's
it's fine. You can continue.
and then we have switches. Second component is switch.
Yes.
Okay. So what is the purpose of a switch? You have a router, that tells how to go from one network to another network, right? Then what will be the purpose of the switch?
Yeah.
So
So
as I said, yeah.
yeah.
So as I said, routers will help you move your traffic from one network to another network. Then you need someone when you want to move traffic within your network, right?
Yeah.
So why you have to move your traffic within your network? Because you may have many pieces in your network. For example, the clear example would be like printer, right? Accessing printers or accessing IP phones in your office, right? You want to call someone, right? Your manager wants to call you. He might be in his cabin, but he wants to give you an immediate call, right? He's going to send traffic from his IP phone to your IP phone so that you both of you can connect for sitting in the same network. Same is the case with printers. So the printer might be sitting two desks away, and you will be sitting here, and you want to print out some important PPTs or important files for some presentation. So you give printer. So you have to access printer is one of a machine that is located in your lab, and you also sit in the same one. So you access the printer so that you will be able to print out your documents. So switch is used to
Mm-hmm.
forward forward. Use the word forward. Okay. Forward traffic
Yes.
between hosts. Host means end devices. It might be your PC, it might be your uh, mobile phones, it might be your printers, it might be your IP phones. Whatever the end device, it marks the end of the network. After that, there is no network. There's no device. Your PC is the last device in the network. Okay, so whatever whenever I say host, I'm talking about devices that ends the network.
Okay.
In host in a network.
Okay.
Okay, use into. Okay, so switch is a L2 device. So as I told, a router maintains a routing table, right? Similarly, switch also does have a separate engine called a switching module.
Okay.
Switch has switching module, switching module mostly ASIC. There is a technology called ASIC.
Okay.
Okay, that stores data in the switching table and refers whenever the traffic is moving towards between host. It helps in fast switching. So the way routing and the switching differs is route it has to scan. So why, as I told yesterday, right? When the traffic goes to the router has to scan the whole routing table. whole routing table. If it has million entries, it will scan all the routing table and it will take a decision after scanning all the tables. So that process is called routing. So routing is bit slow. Okay, but what switching does is it does forwarding. Forwarding means it won't take so much time in taking the decision. So if it has an entry there, so using this ASIC module, right? So this is used for fast switching. I mean, this is the reason for fast switching. So that helps you look into a table called MAC table. Okay, if the entry is present in the MAC table, so like how router has a routing table, switch has a separate table called MAC table. So it takes a decision really quick and just forwards the traffic or switches the traffic in a quick time compared to the routing. Okay. So this is switch. So in switch you have L2 as well as L3. Okay. So previously, what happened is only uh, switch is used for L2 functions, only for forwarding decisions. It won't do a routing lookup. But over the time, the switch has been modified or innovated to perform both the functions L2 and L3. Okay. So why? Because again it comes to constraints, but it cannot replace router in most of the place. But where it will be used, it is used in data centers, right? In enterprise network, the topology will be like this. So end host, then you have a switch, and then you have a router. So mostly this is an L2 device. Okay? It will take your traffic here and it send it to the default gateway.
Yeah.
Default gateway is
Are you showing like some diagram? I cannot.
sorry.
I can
One
see only
second,
the.
I'm not showing. Oh my god.
Yeah, I'm just seeing the. No, no worries.
Sorry. I didn't share my screen at all. I've been using this blackboard to explain the route and switch.
Oh, okay, no.
Sorry, yeah.
Yeah.
But I explain now. Oh, explain this router thing without sharing.
No, it's fine. No worries.
Okay. So the topology is like this, right? You have a PC and then you have a L2 device, which is a switch, and then you have a router. The entry point from your LAN. So LAN is nothing but this region. Okay. The exit point your LAN and entry point to your WAN, right? It marks the default gateway. So this is how the setup looks like. L2 device that does not understand IP address, okay? It understands only MAC address. But L3 device understands MAC as well as IP address. When I say understand, you can configure both MAC address and IP address. You can see both MAC and IP address in the router, but in the switch you cannot see an IP address when it is an L2 switch, right? What happens in some networks, like data center networks, the layer would be like this. L2 switch, then you have L3 switch. And then router. Okay. So why we have this additional L2 switch, L3 switch and router means, I told you about control plane and data plane, right?
Mm-hmm.
So just to, one second.
Okay.
So I told you about control plane and data plane. So why we have divided control plane data planes to make independent decision and have its own purpose, right? So when it's going to be handled by one device, when it's a small network and small amount of traffic, it's fine. But when it goes to a data center, right, the amount of traffic coming into the data center would be high. And if one device is going to perform all the control plane and data plane function, then it's going to be a problem. So that's the reason they have expanded the network into L2, L3 device and then routers. So they have divided into multiple layers.
Yeah, but
Okay.
even if they have decided, the same router is doing both control plane and data plane, right?
Hmm. No. Here in the data center network, at the end it will do a routing lookup.
Okay.
But the LAN, right, the switching layer, so that will become more intense because
Okay.
you'll have a lot of servers, you'll have a lot of requests coming into the end servers, right? So even in the router, you will have 4 routers just to load balance the traffic in a data center network.
Okay.
Okay, so the switching layer is divided into. Let me 1 second. Let me clear this. The LAN segment itself is divided into 3 layers: access layer, distribution layer, and then core layer. Right? So core layer performs most of the forwarding. Okay, distribution layer performs this control plane and data plane kind of stuff, right? It manages both. Access layer also performs forwarding. Okay. So how this is built is, 1 second. So this is built like you have a PC or a server. So consider PC as a server, and then you have a L2 switch. So this becomes your access layer, and then you will have a layer of L3 switch. Okay, this becomes your distribution layer, and then core layer will mark the end of your network. Sometimes some data center network will still have one more switch, right, to switch the traffic towards the gateway, but most of the time it would be just the core layer. Okay, so in real time you will have nexus switches. Have you heard about this word?
No.
Nexus switches. So Nexus switches are very powerful switches from the Cisco inventory. So they'll be dealing with load balancing traffic and handling lot of traffic. So you'll have 10 devices here. In the access layer, consider you have 10 switches, and then once it comes to distribution, it might go around 5, and when it comes to core, it becomes 2. So this is how the ratio is built. Okay. 10, 5, 2. Because core layer becomes more expensive to handle all the incoming and outgoing traffic, and distribution is little. You can have devices which are little what you can say, with little lower configuration, and then switches at the bottom access layer can be pretty much low. They'll be just they'll be used just like a kind of unmanaged switches. Have you heard about unmanaged and managed switches?
I heard about it, yeah. I mean,
So,
yeah, I heard about it. Manage and manage switch.
okay, unmanaged, nothing much here. Unmanaged switch is nothing but you cannot log in to the device and make configuration. So you just have to use as it is what it has come with, right? If you just open it out of the box, and you can just connect the power cable and you just connect the LAN cables and start using it. You can't do any configuration. When I say configuration, it is about a VLAN configuration. You can't divide the network, all these things. So they are like very low cost switches, since you cannot do much with that, and if anything goes faulty, you have to replace the whole device. You cannot go inside and troubleshoot and see where the traffic is getting looped or where it is getting dropped. You can't do anything as such. So you just have to replace it. That is unmanaged device, unmanaged switch or unmanaged device. Managed switches are nothing but they are like little higher end, little bit costly, where it gives the option for the network administrator to configure, troubleshoot, deploy. You can do so many custom tasks. Yeah, so that is managed switch. So in the production, that's what you do. When you are troubleshooting something and user says, I'm not able to access the internet, right? And then it is happening for a specific user, right? And then you come and check on the router side and see if there are user sessions are going out to the internet. Only this specific user session is not coming in. Then you would have to check how this user is connected until your router or a network, end of the network. So if he is connected to the switch, uh, if he is connected to the switch, right, which is unmanaged switch, then you have to bypass his connection to the router. Directly connect the cable to the router and see if it's able to connect.
Sorry,
So
can you
you,
please repeat this part? What are we saying here? I didn't.
So what happens is the end user, right? One of the end users will report that he is not able to connect to the internet since morning or since some days. Okay, and you cannot go into the router. Sorry, you cannot go into the switch because it is an unmanaged switch. Okay, so you have an option to troubleshoot anything from his PC or from the router. Okay, so you go to the router and check if only this user is having issues or other users also having issues, right? When this user reports a problem, right, what you would obviously do is you would check with other users also in that clinic or in that hospital, the medical center, right? So if you see all of the user traffic, right, except this person, then you would have to check whether he is connected to a managed or unmanaged switch. So if he is connected to unmanaged switch, the option is directly disconnect the cable from this portion and directly connect it to the router, just for the testing purpose. See if he is able to reach the internet. So if he is able to reach the internet by connecting the cable directly to the router default gateway, but doesn't work when you connect it to the unmanaged switch, then the problem is with the switch. So you have to move him to different switch. So if you have more than one unmanaged switch in the network, then you have to move this person's cable to another unmanaged switch and give him connectivity to the internet. These are all the basic day-to-day tasks when you're sitting in a small office environment,
Yes.
which has unmanaged switches. Okay. So this is a brief about switches. We will see more about when we are going to do labs and other switching related concepts. But just this will gives you just to understand about these layers. Okay, access layer, distribution core layer. This is kind of a topology for data center network. You won't see this kind of division in the normal enterprise network. Right? But data centers are mostly based on this concept. You have to have access layer, distribution layer, and core layer, and each layer has the switches according to its requirement, the size, the amount of traffic that it's going to handle.
Okay.
Okay. And yeah. Next one is firewall. The next component is firewall. So you would have heard about this firewall even long before, but yeah, the firewall acts as a
It's like a security card.
correct. So you will have PC, and then you will have a switch. A firewall can come here between the router, or it can come here. Okay. So when you will have firewall here is if you manage this device. If this router is managed by you, yesterday you told me about home internet, right?
Yes.
Modem.
Yes.
So you do not you do not manage the modem, correct? If anything happens, if you want to inspect anything on this modem, you call your ISP, right?
Yes.
So in this case, you don't manage this modem, right? In this case, you can't keep the firewall after this because it is an ISP network. Okay, so you can't go and insert your device in their network, in their topology, right? So when this modem is not managed by you, it can be a router, right? So for a small network, you use modem, but for a large network like enterprise grade network, you use router. Okay, that is the difference, modem and router. Okay, and if this router is managed by you, then you can place the firewall here, because until here it is your scope, so you can place the firewall after this. So so at the end of the day, the firewall always sits at the edge of your network, between internet and your network. Clear?
Can we put the firewall between the modem or the router and the devices?
Modem or router. What do you mean
Means
by devices?
between modem and router and ISP usually, uh, like even if it is managed by ISP, can we
Hmm.
connect the firewall to the modem or the router?
After here,
No, after on the left side, yeah, over here. Is it possible to connect there?
you are already connected here. Like you can follow this setup.
Okay. So you're saying for the internet ISP which is provided, okay, that is a firewall, right? Okay, sorry, my bad.
Hmm. This is a firewall, and this is also a firewall. It depends like how far you can extend your network connectivity, right? So uh, if you are manage if the network consists of PC, switches, and then router, if all these three things are managed by you, then you can go with this setup. Okay, place the firewall after the router, but you do not control this portion, right? You control only until this place, right? You control only until this place, then you place the firewall immediately next to a switch, because this portion is external to you,
Yes,
correct?
yes, yes.
So you can't put anything after this. You cannot go until here. You cannot put any devices after the ISP network. It's like handing over your firewall to the ISP. Nobody would do that. Nobody would hand over their device to another vendor or another service provider. So you will have to keep it within your network, but you can just push it too much closer to the exit of your network, right? When you're it acts as it can sit in between your modem, right? It can sit between your modem and router. So if your router is managed, then your modem will be here, right? In this network, your modem is this, right? So it sits between your router and the modem. If you do not manage the router, if you do not manage this router, then it sits between the ISP modem. This is the ISP modem, right? ISP modem and your switch. Okay, clear?
Yeah.
Why? Hmm.
What is the difference between modem and router? Like, can we have both modem and router in one network?
Yeah,
Because you were
yeah, you
saying
can.
earlier for small networks we are using router modem, and for bigger networks we
See,
are using router, right? Is that still the difference?
exactly. Again, yeah, you are coming to that point only. So modem is a very small device, okay? So it cannot handle much traffic, right? So if you have 2 to 4 PCs accessing internet, you can go with modem, okay? But when the count goes beyond when the goes beyond 10 PCs, it cannot handle the traffic. So you need a higher end device. So modem is just like a lower version of a router, right? It can just handle a minimum traffic, it can perform minimal functions, it cannot give you a lot of configuration options. It is managed completely by the ISP. When you're going beyond 10 PCs or more, then you need a router that can handle more amount of traffic. It has bigger CPU. Okay? It has bigger CPU, and you can configure and give a lot of IP address. So what happens is when it is one or two PCs, it's fine. It can give the IP address from the auto configure DHCP. When it goes beyond 10 PCs, right, then you have to configure DHCP also. So to allocate what IP address that you can. So this configuration option not available in your modem. So you have to do it on your router. And also it gives you a very good range of connectivity.
Yeah.
So when it is connected with the modem with two to four PC, you would see the speed you cannot use bone. So what happens is when you are purchasing home internet, right? So they will tell you like I'll give you 1 Gbps speed with fiber link, correct? So when I say fiber connectivity, the port itself will be little different compared to the normal. If you're using DSL, right, digital subscriber line, I'm not sure if you have used that in India. I'm not sure if it still exists in US. Uh, Before fiber connectivity, we were using DSL, this phone lines, right? When you want the internet, you set up a landline phone, and then whether you ask it or not, they will give you a landline phone. You have to purchase a landline phone,
Yes, yes.
and then they'll give you a modem. It can be a Wi-Fi modem or a direct modem. Initially, it was just a direct cable connectivity, so you have to keep your modem very next to your PC, so that you can have a cable between the modem and the PC. Nowadays, they have migrated to Wi-Fi modem. So your Wi-Fi modem can be at any corner of your house. That gives connectivity to whatever the devices connect via Wi-Fi. So when you are going for a Wi-Fi based modem, right, the range for a it cannot handle more than 2 to 4 PCs because it can support only that much level of connectivity, and it cannot offer so much bandwidth. Bandwidth in the sense amount of data that you can send over a period of time, like say per second, right? It can offer you lower bandwidth, even though the service provider tells you that they can support up to 1 Gbps speed, but depending upon your device configuration, I mean the modem hardware configuration, it might end up giving you maximum 500 Mbps, right? And when you go and tell your service provider, see, you told me you can support up to 1 Gbps speed, but at maximum I could see around 300 to 500 Mbps. Then he would suggest you, sir, you might have to migrate to a higher version of a device to support. I told you I can give you 1 Gbps, but at the same time your device should also support taking that much amount of traffic. Right now, your modem is at a lower configuration, so it cannot support traffic beyond that level. So if you want to fully utilize my potential, then you have to get a device with a larger configuration or bigger size. So the router would be, so modem would be like a small matchbox, but when you bring a router, it would look like a book, kind of a big device.
Yes.
And that allows you so many custom configuration. You can set the password, you can reset the password. In some modem, you cannot do the password things and that. Everything will be done. There is something called ONE, optical network edge device, something like that. So ISP does everything. Do not have an option to customize. But if you are bringing in your own router, you can set your password, everything.
Okay.
That's how it is. Yeah. Okay, and next generation firewall. Okay, so this is basically a firewall. Okay, what happens is it helps you filter traffic using the IP address or layer 4. IP address is layer 3 addressing information, and then there is something called layer 4, right? So I told you there are 7 layers, right? L1, L2, L3, L4. So generally, firewall helps you filter, identify traffic using the information received from L3 and L4 layer. Okay. So nowadays we have already migrated to the next next generation of firewall called the next generation. The name itself, next generation firewall. The next generation firewall that detects traffic based on the application. I mean the information in L5, L7, right? It can identify traffic based on the information received from L5, L7. So when I say L5, L7, what does it mean? I told you L3, L4 means layer 3 IP address and layer 4, whether you're using TCP or UDP protocol. Okay, layer 4. When I say L5, L7, it means direct application, whether you're using HTTPS traffic or you're using ICMP. Ping, right? A ping uses ICMP. So it identifies the application directly. So you no need to mention the IP address. So if you want to mention IP address, consider you have 100 PCs, right? Then what you would do? Would you go and mention in the firewall? The old version of firewall would require you to mention all the IP addresses or subnet, old subnet. Some tomorrow, if any new IP address comes and you have to add it to the firewall, then again you have to add it to the firewall, right? So it cannot help you differentiate. And then layer 4 information, it tells you only TCP or UDP, whether you are using TCP or UDP protocol. So the filtering is more of a generic, right? For example, if you want to block only ICMP traffic, right? If someone tries to ping, some attacker wants to check your reachability to your network, right?
Okay.
He simply sends a ping traffic, right? Ping is it's not harmful. So just it is used to help the reachability. If that guy just simply sends a ping packet, right? It can easily come to your network and your network will respond to it, right? So what would happen is nowadays they have stopped ICMP based packets. So you nobody can reach your network using the ICMP traffic just to check reachability. The firewall that sits in between will block your ICMP traffic and it will not let it go inside your network. So
Okay.
to
ICMP is exactly the ping packet, right? Is what you're
ping
saying?
and trace route, ping and trace route,
Okay.
right? Trace route. So ICMP is used with ping and trace route. So they will just when someone tries to ping, so you add a firewall rule. Hey, don't allow any ICMP traffic coming to this port. Right? You send the traffic from here to the outside network. Correct? This is your network from inside. Your LAN towards internet ping should work fine. But if any ping coming from outside towards an inside server, block it. That's how you configure the firewall rule. You will allow inside to outside ping, but you will block outside to inside ping.
Okay.
Clear? So you can use such level of granularity. So earlier you can, with the old firewall, you can block it only with the subnet and layer 3 and layer 4 information. But nowadays we have a new generation of firewall, next generation of firewall that helps you filter traffic based on the application. ICMP, web traffic, or audio video traffic. So consider, Microsoft Teams application, right? So in the Teams application, you can make audio call and video call, and you can also send instant messaging. Correct.
Okay.
If you use a next generation firewall, you can create a policy to block only the audio calls but allow video and instant messaging using the next generation firewall. You can create a filter or a firewall policy to block specific function of the same application.
Okay.
So you cannot, you have such granularity. You don't have to block the entire application, right? So these kind of innovation helps an application to perform more than one function, like Teams. So Teams helps you go with the instant messaging, audio, video. So it integrated all such services in one application, right? So when an application gives you such leverage, your organization security policy should also support some granularity to check whether you can block. So for example, even in YouTube, right? Um you can block specific content.
Okay.
So we have granularities like if you are searching something about movie trailers or something, anything other than educational, you can block such contents. So within the application, you can block certain contents not to be viewed. Instead of blocking. So nowadays in office, that's what they do, right? Say they block all the social media things in general. I don't access any social media from the office network. But nowadays we have a next generation and a firewall applications that blocks certain functions of an application but allowing other functions. So you can still allow your colleagues or employees to access YouTube but do not view unnecessary content. So we have such a level of granularity. Okay.
Yes.
and then do it. So next we have access points. Okay, access points. So access points are nothing but a Wi-Fi range extender. So for example, you have a router, okay? This is in your office network. You have floor 1 and 2, right? You have floor 1, floor 2, right? So consider you bought a very powerful router, okay? Powerful router. So you have purchased one WAN link, right? Internet connectivity, right? So you can't extend, so you can keep your router in floor 1, right? So you keep the router on floor 1. What about floor 2? So it is a Wi-Fi router, that's okay, but it cannot extend the range beyond floor 1. So for this purpose, you cannot buy one more router and buy one more internet connectivity. It is going to be costly for your network. So you have a budget, right? So company cannot spend too much on a network thing just to ensure the reachability or the connectivity. So what is a low cost idea then? Then we have a device called access points, AP. So you extend the range of this Wi-Fi connectivity to the second floor using the AP. Okay. So the people in the second floor, they will connect to the access points. That access point will take you to the default gateway. So the people in the first floor will directly connect to the router using the Wi-Fi router. But access points will extend the range of this Wi-Fi router as if the router is sitting on the floor.
Yeah, so Wi-Fi range extender basically.
Correct.
Okay.
But you cannot manage. This is kind of an unmanaged. You cannot do much with
But
this.
there are
So when you
configurations,
are
right? I mean, we can manage. I mean, we can perform.
exactly, exactly. I will come to that next. But when you want to just put one access point, you cannot manage. It's mostly an unmanaged, just an Wi-Fi range, right? And that's when your enterprise grows big, right? So you have so many floors, like 10 floors, or within the floor itself, if the floor is expanded beyond 2,000 square feet, 5,000 square feet, right? When you have such a large office, then you need more access points, correct? Access point 1, 2, 3, 4. No? In each floor, you have 4 access points. So when you have such large fleet of access points, you cannot use this word unmanaged. You have to have a way to manage this access point. What is the purpose? Why do we need to manage this access point when it can work without management itself? Why we need is sometimes your access points will be overloaded, right? For example, let's say 4 users are present. Okay. So what you would think when you have 4 access points, you would think each user is connected to each access point, right? Just for load balancing traffic. Sometimes all these guys will sit next to a cafeteria, right? The access point which is located near the cafeteria will have to serve all these 4 users. So all these 4 users, instead of connecting to each access point, they will start connecting to the nearest access point, correct? So all the other 3 would be lying low. Nobody, they will be lying workless. But this access point would be very busy serving all the 4 connections. What would happen? It might go down. Right? The access point might go down because it was continuously queried by these users directly on this. So as a network administrator, you cannot go walk in and check what happens to this. So that's when you need a special device called WLC, wireless controller. Okay. So this wireless controller helps you manage all the access points in a network. You can monitor the health of the access points. You can check how many users are connected to each access point. You can check what is the CPU resource of this access point. You can check what IP address are given by this access point to the users, right? You can perform so many monitoring activities. Second thing, tomorrow if you are going to upgrade the access point software, right? So you cannot just walk into each access point location and push a software update and wait for it to complete, knowing whether it is completed on time or not, or if there was any failure, how do you see those failure errors and take necessary measures, right? So this WLC helps you deploy the software upgrades, maintenance, everything from one point. Second reason for having a managed access point network, right? And then third one is, consider you want to push, so for example, if you want to do a password rotation, right? So enterprises, they try to change the password every 3 months, some policy, right? They'll have some enterprise level active directory, GPOs, group policy objects, right? So this configuration helps you reinforce the security limitations within the company. So this changes the user, for just check the firmware upgrades, or if you want to make any configuration changes, if you want to update any certificates, all this one through this group policy objects from the active directory, right? So all these things can also be installed in these access points through the WLC, right? So that is the reason, when you have a large fleet of access points, you go with the WLC. So WLC is used to manage your access points. So like life cycle management, deployment, maintenance, configuration, all these things you can do it with this wireless controllers. So with Cisco, there is something called a DNAC. Okay? DNAC is nothing but DNA center. So it is one of the product that helps you orchestrate the wireless architecture in your office environment. Okay, and then the next thing is endpoints. So I told you already, when I say endpoints, I'm talking about host. Endpoints nothing but the last point in a network. For example, router, switches, PC. Right? For a switch cannot be last device in the network, because below switch you have one more device, right? And router, it cannot be last device in the network, because below router, switch is dependent on router to exit to the network. Similarly, the PC is dependent on to exit to your internet through the, it goes to the router through the switch. The switch is not the last device in the network. And then what is the last device in the network? Your PC, right? It can be your PC, or it can be your IP phone, right? IP phone, or it can be your printer device, right? It can be your printer device, and Xerox machines, whatever it is, if you connect it to the network.
Tablets.
Yeah, tab, mobile phones, right? Whatever. So all this forms endpoints or end hosts. Sometimes in the data center network, it is a server, right? Server, end host. You can call it as endpoint or end host. Okay. Now, so there is one concept called PoE. Have you heard about this?
Yeah,
Power
power over
over
Ethernet.
Ethernet, right? So what happens is, the switches
Yeah,
do not have a
I
separate power module,
yeah, I
right?
saw this in
Just
my clinic because we
sorry.
have yeah, I saw this in my clinic because we have a
Mm-hmm.
limited number of Ethernet ports
Hmm.
that can actually be connected. Not limited number of ports because we don't have enough power cables for
Exactly.
the devices. So what they do is they use this cable which supplies power to the phones. So I have seen this being used for phones, for the
Exactly.
landline phones. Yeah.
So to make your network to make your device to be little compact, when it is in small size, when it is going to cater to very small number of clients, so you use this power over Ethernet, mostly used between your switch and the IP phones, right? So where you do not have a separate module on the phone to power the phones. So this power or Ethernet technology is used in such environments. But when you go for a larger network, you don't use this power or Ethernet, right? In my experience, when I work on this data center based environment, the switches and routers will have two separate power modules just to power the device. In case of power failure, if one module goes down, the other module is available to supply the power. So that's how the robust device and demanding it will be on the data center. We tell you, right? AI is going to consume a lot of power. It's going to consume a lot of water. Why we do is because you are going to have a device that is going to consume power like anything. That in turn will generate heat to a humongous amount, and to control that heat again you have to use cooling system. That cooling system again will generate more amount of heat, right? So all because of the power consumption, the amount of energy required by the devices. So power over Ethernet is not suitable for a data center kind of an environment, but for a smaller network or to power up small devices in the end, where you don't have to provide. The thing is, if you're sitting in a cabin in the cabin or a row desks, right? Sometimes the office would be like row desk, like you will have people sitting here, right? So you don't give them lot of power options to connect. So in that case, whatever the network devices they have, the IP phones, right? The printers, all these things will be powered through the power over Ethernet cable. So the power over Ethernet cable, again, it is little bit costly compared to the normal Ethernet cable because it performs an additional function and has to carry power, both power and data. But that's what it is used for small network connectivity devices.
Okay.
Yeah, so the thing is, the basic, the common scenario would say is if any of your device does not function, right, it does not turn up, do not confine this as a power issue or the hardware failure. So you have to check with, first question you have to ask is whether the RJ45 cable connected to this small appliance, IP phone or printer is, check whether it is a PoE cable or not. Because sometimes both PoE cable and the RJ45 cable look similar,
Yes.
right? So we would get carried away saying like I have replaced more than one cable and still the device do not power up. So first thing is you need to check whether the cable is PoE or not, and then you change the cable according to the PoE connection. So that's something that we have to take. We have to understand. We have this tech. We have this feature with this RJ45 cable, and consider when you're troubleshooting this issue.
Yeah, because the switch for RJ45 will come from one switch, and the cable for PoE will come from a PoE switch. So what you're
Correct.
trying to say is you have to check which cable is which, right?
Correct. So you have the when you are using that when you are using a PoE cable, so you have to verify the switch is PoE enabled switch or not.
Yes.
Right? You have to have that information in your inventory. So when it does not support, that's why I told, right? In the data center network, you don't have that PoE kind of switch. Each switch has two separate power modules. So one power supply module is a PSU, power supply units. So if one PSU fails, other one will still continue and delivering the power, but generates an alarm saying one of the PSU unit is failed. You have to consider replacing it. So that's what, like PoE switches are like used in a very small environment where it where the number of users not it's not going to handle a lot of traffic like other data center switches.
Yeah, so
So
instead of
that's what.
PoE switch, it is like direct dedicated power cable
Hmm.
that you are
Correct.
saying, right? It is there for data
Correct.
centers, but if it is coming through a Cat 5e cable, it is still considered as PoE cable, right?
Correct. Correct.
Okay.
So this Cat 5, Cat 6, it helps you extend the range, the amount of range that it can extend the connectivity, right? So, for example, this Cat 5 cable, right, within whatever you see Cat 5, Cat 6, Cat 6e, Cat 5e, all these things will be used to deploy within building, and you cannot go outside the building. So when you want to extend it outside the building, then you have to extend it with the copper cable or the fiber connectivity. Again, the fiber connectivity can extend only for a certain range, let's say like 1 kilometer. So extending the fiber connectivity beyond 1 kilometer, first thing, it is going to be costly. Second thing, when it breaks, it's going to again make it very difficult for a replacement, and it's going to incur large amount of cost. But fiber connectivity gives you very good non-interference link. So you won't have so many distortion. You will have very the amount of data transmission, the success rate would be like above 90%. But it cannot support you for a larger range. So that's when you go for a copper connectivity that helps you span more than the fiber connectivity, like let's say like 5 kilometer range. So even, but you will have more magnetic interference, like the success rate for the data transfer is around 75 to 80%, but it gives you a larger range compared to the fiber connectivity with less rates. So all these Cat6 cable are like supposed to be used within this building. And then if you want to go outside the building, extend the range, go with the fiber connectivity when it is around 1 kilometer to 500 meter. When it's going to go beyond 1 kilometer, then go with copper connectivity. The cable type differs.
Okay.
Okay, this power over Ethernet is just within your LAN network. When you're going to go outside, it's going to cover your WAN side. So WAN side only you will use your copper and WAN cable. Sorry, copper and fiber cable. So within your LAN, you can just stay with your PoE or your 45 Cat6 cable. All these things would work fine.
Okay.
So, so we have just completed the role and function of network components now, and from tomorrow, yeah, let's have a continuous session this week, okay?
Yeah.
Because it's most of like a small theory concept, so
Okay. Yeah.
no need to give a break as long as you're not busy with other office tasks or anything. Like have a schedule this week available for the whole week, like Monday to Friday. Then we can let's complete this network fundamentals continuously without giving a break. And then once we start the second module, network access, which includes lab, then we can just give a break between days like Monday, Wednesday, Friday. We can have 3 days in a week, and allowing one day to revise and test things in your lab. So you know about the packet tracer, right? Or do you have a GNS3 in your lab?
So we once we were having a problem in our clinic wherein after 32 seconds
Hmm.
the call used to end. So I used
Hmm.
ChatGPT to understand why this problem was happening, and in
Hmm.
that one it told me to do packet analysis. So after that I downloaded this Wireshark, I think, application,
Hmm.
just to
Hmm. Hmm.
understand how the packet flow is happening. I got to learn
Hmm.
about the handshake protocol. So I just
Hmm.
have some beginner experience. I was not able to solve the problem. That was bad for me, but at least I got some what do you call idea about this thing.
Okay, okay. Yeah, Wireshark is like an advanced tool to capture the packets and see what is happening, like who is
Yes.
sending the reset and who is trying to disconnect. But GNS3 and Cisco Packet Tracer is like an application that helps you deploy devices like a real-time environment and configure and bring up the connectivity and see how you can do a config. It is like a pre-prod, like lab kind of environment similar to your production. So you can test, check commands, everything in the lab before you actually test in the lab, before you actually deploy it in the production network. For example, when it can be useful is consider a manager comes and tells you to deploy 2 VLANs in your network tomorrow and asks you to prepare some technical implementation document for change approval, right? So either you can refer the previous cases, previous change requests and see what was done for a similar request in the past, or you can directly go to your GNS3 or Cisco Packet Tracer lab and see what are just create a VLAN step by step process and see how the VLAN is created, how you allocate the ports to those VLANs. and how the ports remain intact to that VLAN, and how the traffic is really not mixing up with VLANs. All these things you can test it in the lab and prepare the technical implementation document more confidently, right? So you have tested things in the lab. That's when you go on able to prepare this document. So it is useful in such cases to prepare for your change activity with some hands-on practice before the actual activity in the production. It stands good for a like lower level implementation, but when you are going for a large level migration, like you are considering you're migrating from Cisco to Juniper, right? Where you have to migrate your routing protocols, you have to migrate your switching protocols. So that is going to be a big deployment. For that, the way of preparation is different. But for such small tasks, you can use this lab and make yourself confident before the production change.
Okay.
Okay, so you have Cisco packet tracer in your laptop,
No, no.
or do they allow you to install that external software?
Well, I have my personal laptop, so I can use that.
Okay, then okay. So yeah, it's better to have a Cisco packet tracer. I mean, it's not going to be required immediately, like for the next 2 days. But if you have it ready, then it will be easy. So just develop the Cisco packet tracer application in your uh, laptop. It requires you to register with the Cisco website. Okay. So to log into that application, even though you download that application to your laptop, it requires you to log into the Cisco website. So to log into the website, you should have pre-registered. So complete that procedure in next 2 days and have that software. If you have any problem or any doubts installing this Cisco package, just let me know. We can do this together. Otherwise, it should be a simple task.
Okay.
Okay. So okay, Mustafa. So we'll see you tomorrow at the same time. Yeah, I'll most probably be like responding to your messages immediately, or I'll just be ready for the class before you message me. In case I do not respond to your messages, just give me a WhatsApp. Yeah,
Sure. Okay.
okay.
All right. Thank you.
Thanks for the time. See you tomorrow.
See you tomorrow. Bye.
Allah Hafiz.
Allah
Bye.
Hafiz.